Hello YouTube, DVD here. Today on the Lover's Day I'm gonna using a LUA Engine to demonstrate how your controller parameters can affect your transition processes and also the parameters of your plant. So let's start, shall we? First of all, I'm gonna use my LUA code written for the LUA Engine. Here I'm using about 5, I guess, let's say 9 objects, which of them generate my reference signal. So I've got many signals to test today on my plant, which is actually a simple ball with some mass, and I'm using apply force to control this ball up and down. This is not Gax mode, this is slow, by the way. So let's start the application, shall we? Drag and drop the folder onto the LUA Engine, and here it goes. Here's my ball, and the blue one is actually my reference. I can have manual reference, sinusoidal signal, trapezoidal, triangular, saber sawtooth, left, right, half circle, trapezoidal, white noise, and this one is actually a custom one. This one I used to create a function maker that can make mathematical functions to work as a LUA function. I can set here x and it gives me the value of this thing right there. And I scale its period to fit my on the function's borders. Here I'm taking from 0 for 2 to on the x-axis, and let's start with a simple sinusoidal reference, or maybe the manual one. I can refer that. I can adjust my controller parameters. Let's say my proportional part is quite big and the diff part is quite large too. It works quite nice, I guess. I should bring down more of the D part. Let's see how it behaves. Yep, quite nice. Let's try now the different thing, sinusoidal reference. This, by the way, behaves like that because I'm recording a video. Let's see another signal. My diff part should be lesser than that. So I'm not going to stop my ball. Let's try different signal. Triangular. I quite like my objects for generating those signals. It reminds me of my university and different signal will be that one. But of course you can tune up your PID controller like that. Also the robusting is very important, because if I change my mass right there, it will affect many things. Like that, for example. Here my D part is quite large and I really can handle that. $630 is quite nice for those controller parameters. My system behaves quite nice. Let's try different reference. Do you see those curves right there? If my ball has less mass, this will be more smooth here, without this creepy overshot which I'm getting. The white noise is just raping my system, literally. This is the functional reference. It's calculated using my function right there, which I can set using a string. My proportional part needs to be a little more bigger than that. See the front curve? My transition process is quite fast, and if my proportional part becomes bigger, that surface right here and right here becomes smaller and smaller, like that, for example. See? That's how the robust setup of your controller will affect many things. If it's more robust, then that means that your controller can handle a larger range of plants, which will tell me that my mass will vary on different values, like here 630. If I make my ball quite massy, here you can see the overshots about 1000. It still handles quite nice. Yes, that's I want to accomplish. See the overshots? Don't say I told you so, because this thing is actually normal for a plant like that. If your controller is proportional part is quite large, you can get those overshots with no problem. But here let's see how this thing will do with a larger period. the transition process. It hesitates a little bit, but it handles quite nice. Let's see different signal now, like the triangular with its rises and falls. You see that right there. If my bow is lighter, that will be following the blue curve, but it's still 1590 units of mass. I don't know exactly how LUF represents the mass right there, but I guess it's okay, just for testing stuff. See, my controller here is very robust, so it can handle a wide range of masses, and that means wide range of systems with different bow. And how my bow mass will vary, you will get different plants, and my controller is able to do those things. Let's adjust the mass quite much, so about 500, so there, and try different signal, see how it follows the curve quite nice. So here we have a lighter ball with the same controller. Really transition process. Every automation engineer's loved one. Yep. And that's how your transition process can affect your controller parameters. I hope I just clear the robusting a little bit. Have fun with your LUF projects, and see you next time. Happy coding, guys.